Okay, this is the third and final video in our series introducing the sine and cosine graphs. In this section, we're going to practice drawing them ourselves, and then for homework, you'll do some investigation about what they look like when they're transformed. So for the graphs of y equals sine of x and y equals cosine of x, the period is 2 pi, and remember the period means from a max to a max or a min to a min. It's one full cycle. So for both the sine and the cosine, one full cycle is 2 pi. The amplitude for both the sine and the cosine is 1. That means that from the central axis or the principal axis to the max is 1. From the central axis or the principal axis to the min is a distance of 1 also, negative 1. That means that altogether from the max to the min is a distance of 2. The principal axis for our sine and cosine, our unshifted sine and cosine functions, is the line y equals 0, which is just our x-axis. So that is the dashed line that splits this and makes it symmetrical from top to bottom. It's not symmetrical if I folded it in half, but it is repeating because it's periodic. Okay, so immediately, hopefully you notice, now that you see the sine and the cosine, the black one is the sine, and the green one is the cosine. Now that you see them plotted on the same coordinate plane, you hopefully are recognizing that the graphs are shifted, because if you look at where pi is on the sine graph, it crosses the x-axis at 0, and the cosine graph did that at pi over 2. So you can see below there's an example of how they are shifted. You could take the sine graph, and that's equal to the cosine graph shifted to the right, pi over 2, or the cosine graph is equal to the sine graph shifted to the left, pi over 2. Both the sine and the cosine are called 5-point graphs because the important features of one period occur at 5 points. So if you know how to graph those 5 points or find those 5 places, then you can graph any sine function and any cosine function. The sine function has 3 x-intercepts and a max and a min. Those are the 5 points. And the cosine has 2 x-intercepts and 2 maxes and 1 min. So I'm going to show you how to graph one period, and then we'll practice graphing the rest of them. Then you'll have paper where you're just going to draw them over and over and over again, because it's actually kind of hard to draw them if you haven't had practice. You need to make some curves, and they can't be pointy and all that kind of stuff. And then just as a preview, you'll use Desmos for your homework to explore the transformations. But before we explore transformations, let's figure out how to graph them just the way that they are. So first things first, I'm going to zoom in on the sine. All right, in order to draw the sine of x, the first thing I want to determine is the period. The period is equal to 2 pi. So I'm going to write 2 pi. And the amplitude is equal to 1. The reason that's important is because it tells me where does one cycle start and where does one cycle end, and then how high does one cycle go and how low does one cycle go. So I said that our sine graph has 3 x-intercepts, a max, and a min. But usually I do it like this. I'm going to plot the starting point at 0, 0. Because there's no shifts. Then I plot my end point at 2 pi because that was the length of a period. Because the sine has 3 x-intercepts, in the middle of the start and the end is where I cross the x-axis again. So because the period is 2 pi, that happens at pi. Now I have basically a section of graph that I have 2 sections. I have from 0 to pi, and I have pi to 2 pi. In my first section, when I split that in half, I end up with my max. So I'm going to use 2 lines just to give me a little more space. So my max is going to occur at 1. In the second section, I split that in half, and I end up with my min. My min occurs at -1, so I put a dot there. Now I have I have the 5 points I need in order to draw my curve, and I connect them with a smooth curve. So the more you practice this, the easier it gets, and it's going to be hard for me because my pen's a little wonky, but basically it looks like that. Notice everything is curved, it's not pointy, etc. Okay, if I am repeating this, essentially this is the magic of computers. This curve that I just drew is repeated over and over and over again. So if I just moved it over, that's the same graph. And I can put it back. There's the same graph. Okay? So to draw 2 periods and a period in the negative direction, we would start at -2 pi. Our period is 2 pi, so we end at 0. Halfway through, we cross the x-axis again. Because we're between the -2 pi and -pi, we would have a max. Halfway between -pi and 0, we would have a min. And then we can connect our dots with a smooth curve. And that's how you draw the sine graph. So I would think about it this way. You're going to plot your start. You're going to plot your end, which is the length of 1 period. In the first half, you have your max. And in the second half, you have your min. I guess I shouldn't, it's the middle of the first max, so maybe you want to call that the first quarter is the max, and the third quarter is the min. I don't know if that's more helpful. All right, there's your sine graph. Okay, let's scroll over and we're going to do the cosine graph. So same idea. What's my period? The period is 2 pi. What's the amplitude? The amplitude is 1. I know that because I'm looking at my function up here, y equals cosine of x. There are no shifts or stretches or anything like that. So I'm going to start with my max. So here, the cosine, you start at the max, which is 1. So that's our first dot. And the period is going to end at the max, because a full period would be through the minimum and back to the maximum, which means that halfway is going to be our min. So at pi, we would go down to -1, and that would be our dot. So in between those, I now have from 0 to pi, I need to cross the x-axis at pi over 2. And in between pi and 2 pi, I need to cross the x-axis at 3 pi over 2. And now I have my curve, and I connect those dots. This one is a little, like you kind of have, it's like you're coming down from the max, and then you connect, and then you're going back up to the max. So it's like you have sort of this like fluted tulip shape. Again, notice, because these are periodic functions, if I just grab that curve that I drew and I shift it 1 period over, I get the repeated graph. There it is in my negative quadrant. If I grab it and shift it 1 period over, there it is back in my positive quadrant. So I'm going to go to my negative side. It was starting high, which means it ends high. Which means in the middle is the min, which means halfway between those points, it is crossing the x-axis. And there is my curve repeated. Okay? All right, at this point, you can go ahead and stop this video. Well, it's going to be over in a second. And you're just going to practice drawing your sines and your cosines. You've got a piece of paper. You will do all sines on one side, all cosines on the other side. And then for homework, you're going to explore with Desmos. Thanks so much. Bye.